right, this is the answer key to page 47 in the packet. We're into the last topic of Unit 5. This is not a joke. This is not a drill. This is the last topic for Unit 5. So we'll spend some time practicing and assessing here these next couple of days. But points on a circle. We're into some geometric proofs or coordinate proofs when it comes to algebra and geometry. For example, determining if a point is in, on, or outside of a circle. So the distance formula is not only used to find the distance of two given points, but can be applied to find the distance between points of an object. A circle contains a radius and a diameter. A radius is half, that's a typo, half the diameter, and the diameter is twice the radius. The radius of a circle is equal all the way around. That means that from the center to a point on a circle, it's the same distance. So again, we can determine if a point is inside, outside, or on our circle. First, we'll determine the distance from the center and a given point. So we want to find the radius. We want to be able to find the radius so we can compare another point. So how do we find if it's inside, outside, or on? We're going to find the distance between that point in question. So if the distance is smaller, it's obviously inside. It's smaller than the radius. It doesn't make it to the edge of the circle. If it's outside, it's going to be greater. If it's equal to, it's going to be on. Please feel free to rewind, pause, and play this video to fill in these blanks. Let's flip it over, though, to page 48. So I'll give you some examples to practice. So the first example here says, determine whether a point lies on the circle whose center is point C, which contains the point P to justify it. So P is on my circle. It says it contains point P. P is on my circle. So there's a couple ways we can do this. We could certainly graph it. So let's see. Point P determine whether point A lies on a circle. So this is the point in question. I hate the way some of these problems are worded, but I didn't write this worksheet, y'all. So this is our point in question. Determine whether point A lies on the circle. C is our center, and it contains the point 0, 2. Okay, so if it contains that point, that means I have a radius of 2, and I can draw in a circle. We've learned how to graph circles last week. Okay? So we want to know if 1 square root of 3 is on that circle. So we need to know approximately what the square root of 3 is equal to. 1.7. So we could say like 1, 2, like maybe. Okay? This would be one where graphing it's not a good option. We want to be able to find the distance. So this is an easy setup. We know our radius is 2. So I'm going to use the distance formula, and I'm going to say, all right, x2 minus x1 squared plus y2 minus y1 squared, taking the square root of it. So this is going to be negative 1 squared plus negative square roots of 3 squared, still taking the square root. So we know this is 1 plus negative square roots of 3 squared. And I'm just going to put it in my calculator so I can be certain. A negative times a negative is a positive, and that squared undoes the square root. So 3 is my answer here. So we have the square root of 4, which is 2. So I have a radius of 2, and I have a distance of 2. This is on my circle. Okay. Let's try the next one. Again, point A is the point in question. C is my center, so 1, 2, 3, 1. I have let's see, point P, 1, 2, 3, negative 1. So again, I have a distance of 2. This lined up nicely. So 1, 2, 1, 2, 2. And we want 5, 1, 2, 3. So graphically, that's outside of my circle. Well, let's check this algebraically. So I'm going to find the distance of this first to prove it's really a distance of 2, which I guess technically we can. The x values match up. So if I look at the y values, from 1 to negative 1, that's a distance of 2. So I'm going to double check this point to my center. So the distance is, that's the distance I'm checking, by the way, not just any distance, the distance from that point to the center. So x2 minus x1 squared plus y minus y squared. So this is negative 2 squared plus negative 2 squared equals 4 plus 4, and that's 8, which is 2 square roots of 2, which is approximately 2.82. So here we have a radius of 2, and I've found a distance of 2.82. 2.82 is greater. That's outside. Let's go ahead and pause the video and let you try this one both graphically and algebraically by yourself. When you resume, the answer will pop up for you to check. Okay, you've resumed your video. I found a radius of 5. Again, my y values matched up, so I can find that horizontal distance from negative 1 to 4 is 5. I graphed it and I plotted that point A. And it looks like it's on my circle, but I have a hard time believing that because I can't draw a perfect circle all the time. So if you solve it algebraically, it does match up and it's on the circle. I'll upload some extra practice on the blog if this concept's a little bit tricky for you, just for you to practice as you need to be comfortable with the topic. Tune into the next video for more geometric coordinate proofs.